So this is an example dashboard for monitoring an AllegroGraph instance that exposes a couple of metrics, shows a couple of metrics here, and they are organized into a couple of tabs. The organization system is slightly different on AllegroGraph side. I'll talk about that in a bit. Here, it's convenient to look at this visually because these are the convenient categories. So the first category is the system metrics. These are the machine stats, VM stats, like the CPU usage, RAM usage, the system processes, disk usage, etc. You can see that a bunch of metrics are organized into only 4 graphs, basically. The CPU usage shows all the different categories like the user time, system time, I/O wait, and so on. RAM usage is this convenient striped graph where you can see the swap usage, buffer memory, cache memory, anonymous memory, and free memory. System processes and disk usage is also pretty straightforward. This includes the swap in and swap out operations. This information is available in AllegroGraph in WebView in a different format, not the Prometheus, and you might be familiar with this if you ever used the server stats page. This information pretty much mirrors what AllegroGraph shows here in WebView, but the Prometheus metrics have much more information. In particular, the second tab here, the second panel here is the server panel. This exposes the internal processes counts and HTTP statistics. So you can see the number of session processes in AllegroGraph. Sessions are dedicated processes for handling query triple store operations from a particular user for a particular triple store. So they are dedicated and always ready to respond for a particular repository to a particular user. We document the use cases for the sessions in our documentation. And backends are similar to sessions, but they are shared between many users. So a typical AllegroGraph server would have a couple of backends and normally 0 sessions because sessions are started on demand. Here you can see there's 1 session because this is the way currently system is loaded and there are no running backends. HTTP statistics are the HTTP requests and free HTTP workers. This is very useful in cases where AllegroGraph is being bombarded with a lot of HTTP requests, and you can see if the all the free requests are consumed, then this might be an indication that you are at the limit of AllegroGraph HTTP responsiveness. Right, and the most interesting tab here, I guess, since this information is also available, system information is also available in the WebView, the most interesting part here that is not available in the WebView is the repository tab. This is a set of metrics that is collected on per repository basis, and it is mostly related to the triple count and running queries. So the for example, currently this particular repository is running a load of Bitcoin transaction graph. A couple of processes are running doing the load in parallel. So you see that the number of triples is constantly growing in the background. The triple indices are O scores. These are the overlap scores for the triple indices, which indicate the health of a triple index and its ability to quickly find the ranges of triples. This is growing and then suddenly dropping, which means that the optimization happened, and that drops the overlap score down. And this happens as the number of triples grows. As soon as the value reaches that close to 25, which is the threshold, that's the trigger for the optimization event. And another set of graphs here are query rate, query latency. Query rate is the number of requests per second. much and how it changes over time. Query latency is the average response time per query. Query failures is the percentage of failed queries. It's currently 0 because, well, usually this would only show the queries that fail due to a timeout or a user cancel request. And query caching is an interesting graph that is not showing anything here because the current process is not running cached queries. But what query caching shows is the percentage of cache attempts, how many cache hits there were, and how many cache misses. And this is very useful in cases where a system is configured to use query results caching, and you can see a lot of cache misses. That means that the rate of data additions to the database and the queries is at a point where the queries cannot benefit from caching, because as soon as they run a query and cache the results before they run the same query again to read the results from cache, the database state changes, so the cache is invalidated. So this is a very useful graph to look at when we are setting up query results caching. This will show how beneficial query caching is for the current configuration of the repository and the types of queries that are running against it. Later, I will show this caching graph, like actually populated, showing some information. Currently, it is no queries are being run with query caching enabled. Right. So the way this is configured in AllegroGraph, and let me go to my terminal quickly and show you the configuration file. So this is an example of Prometheus config. You can see here that AllegroGraph exposes a couple of a single endpoint, but the categories of metrics are split into, there are several categories of metrics: the jobs, replication, indices, systems, and queries. This is not a standard way to do this. This is like a graph-specific thing to separate, to provide different categories of metrics. And the reason for this is certain metrics take a long time to compute, like replication. So you might want to be able to configure certain categories to be run, say, every 5 seconds, but other categories every 20 seconds. That's why they are split into these category structure, and you can provide the category as a kind HTTP query parameter, and that'll give you only the metrics for that particular category. In this config, all the queries, all the categories are pulled, all the metrics in all the categories are pulled every 5 seconds. This is good enough for demo. And the Grafana dashboard that I just showed is available in AllegroGraph examples repository, along with the example Prometheus configuration. So you can go to the AllegroGraph examples repository and get both the graph configuration, Prometheus configuration, and the Grafana dashboard JSON model, and use them directly. This AllegroGraph example directory is also linked to from our documentation on the monitoring features of AllegroGraph. Right. So here you can see an example of a synthetic process running, querying the same database while the load has been stopped. And the process is synthetically configured to fail in about 10% of queries. So the query is simply generated incorrectly and it fails during execution. And 50% of the queries attempt results caching, but the different kinds of queries are, there's a lot of different kinds of queries, 10 different kinds of queries, in fact. So the caching is not 100% there. It only happens for the case where the results caching happens to be enabled for the query, and also this query has already been executed before. And as you can see, the total cache attempts is rising to about 50% because this is the expected number of queries that we are attempting to cache. The cache hits is lagging behind, but also rising because as soon as all the kinds of queries have been executed at least once, then the cache hits will be at the exact number of at exact percentage as the cache attempts. And cache misses started quickly rising because of the different kinds of queries being run, but after all of them have been executed at least once, the cache misses is going down. So this is an example of the query caching introspection, where you can see how your system is benefiting from query results caching. And this is possible with the query caching metrics exposed in Prometheus. Right. So let me quickly talk about Prometheus itself. So this is a popular tool used for collecting information from various systems in a very simple format and aggregating that information in the database, and then exposing this aggregated information to other tools like the Grafana here. And we've been asked the question whether AllegroGraph can provide the information available on this page server stats in different time ranges, like the last 15 seconds or the last 6 hours. And this is what Prometheus is exactly for. This is a system that collects data indefinitely into the internal database, and then using the Prometheus query language, you can get whatever range time range from that database that you need, and you can visualize it using Grafana. So Grafana, for example, here it exposes very convenient settings like look at the last 5 minutes or look at the last 15 minutes and so on, and refresh however often you want. This example dashboard, by the way, it is configured, it is implemented in a way that automatically pulls the information about the available catalogs on the system and available repositories. So you don't need to configure these graphs manually. These are all implemented as Grafana dashboard variables, and you can select the repository that you're interested in. For example, we can look at the system repository. Not much is happening there except for a couple of thousand triples for the audit log and other information. If we go back to BRDF repository, you can see that even though the system repository was in the systems catalog, these two variables are tied together. So as soon as you switch to the BRDF repository, the dashboard knows that BRDF is actually located in the other catalog. So the value for the catalog variable is switched automatically. You don't need to do this manually. And right, and this is mostly it for the dashboard. All the metrics that are currently exposed in AllegroGraph are available on this dashboard, and you can tweak it to delete unnecessary information or maybe separate some of these graphs into separate graphs. For example, you may want to add the query failures percentage to the query caching graph, so all of that information is in a single graph, or you can split it into separate graphs. So each panel contains only a single graph, and so on. Prometheus is using a very simple textual format, and the endpoint exposed by AllegroGraph is the standard one. So the way this works, let me make my screen a bit larger. The way this works is you can run a curl command to the AllegroGraph endpoint. This is using the standard testing username and password. The endpoint is metrics, which is the standard Prometheus endpoint. And when you run this endpoint, you will, sorry, this is HTTP. Luckily, you will not get anything because it requires the kind specified for the reason I mentioned earlier. We want to ensure that the user doesn't accidentally run a metrics collection that takes a lot of time. So let's say we want to look at the kind queries. We specify the kind equals queries, and we get the textual output. And this is how it looks. The metrics are returned for every repository that is currently active. So if you're not using a particular repository, but it is on your system and hasn't been used in a while, it will not show up here. This is done to avoid opening repositories that are inactive and spinning up the instances, so on. And you can see Prometheus format is very easily readable. It's textual. You can use various queries to query this information, but of course, it's not as convenient as just using a Grafana dashboard that visualizes all of this. I already showed you the configuration file for Prometheus that exposes all the metrics available in AllegroGraph right now, and the dashboard model. You can see here the same dashboard that I was showing earlier is available in that graph examples repository as a JSON document. So you can just take it and import it in your Grafana instance and see all of this. There's no point in looking at this file too much because it's just a huge dump of all the settings for that Grafana dashboard. Right. So as I mentioned, the metrics visible here are almost everything that the AllegroGraph exposes right now, but we are actively working on adding new metrics. In particular, we are working on implementing metrics for the LLM functionality for AllegroGraph. So metrics like the number of external LLM API calls and so on. So all of this will be available in AllegroGraph at some point. Right, and this is pretty much it.